Everyone. So this will be the first video of our new series called Counting Numbers to Quantum Computers, right? So basically, we'll start with basic videos of how number system came into existence and how we evolved through various number system like Roman numerals, and then we have Arabian Hindu Arabic number system, and then how we use binary number system, and so on. How gradually had computers, and then we use like calculus and like so many things, and then we something we came out about imaginary numbers, which is very hard to wrap around, right? It's very difficult to imagine, right? And it's an imaginary number, and then we came to know about quantum number, which is a different ball game, like superposition, entanglement, right? All the crazy stuff. So if you're tired of watching quantum videos, which they use this buzzword of superposition entanglement all the time, and you're getting confused. So I think you're at the right place. Or somebody kid who doesn't understand how this why 2 plus 2 is 4, not 3 or 5 or any number, right? Where this number comes from, what actually this symbol 2 actually means, what the plus sign means, why do we actually need a number system? Like if you have this basic low level question and you don't have answer for it, you're at the right place. And we'll start with the video. And the goal is to not to teach you about the math, but question yourself and like discover the math by yourself. Like you can come up with the own reason. It's like reinventing the wheel, right? So we'll start with the evolution of number system. So evolution of number system is basically if I have to tell you, like going back when we were not as modern as we are today, we were very primitive. When we were in caves, in that time, caveman has caveman has a way of doing things. They don't had language back then, but what they used to do to like there was a caveman who has like livestock, and he was a kind of farmer, and or and he has like three goats or sheep or something like this. So how would you make sure that they are exactly that number? So when they go in the morning for grazing, and evening when those sheep or any animal, the livestock they have, come back, how they know that they have the same count, or one of them is lost, or one of them being eaten by a tiger, or it is being stolen by somebody? How would you know that, right? So they decided to come up with something called hieroglyphs, like Egyptian hieroglyphs, if you heard about. So what they will do, basically they draw the number of livestock they have on the wall. Let's say they have three sheep or two goats or something like this. They draw their painting over there, right? And the problem with this was the first basic number system, right? Just to count things, count the livestock. And the problem with this number system is that, let's say for 2 3 it's okay, but when you have multitudes like 20 30, then you don't have that much wall enough, right? And if somebody is lost, then how would you cancel it? Then you have to go erase the wall and then re again. Or if the number goes too much, like more than 40, now there is no place to accommodate on the wall. So this was a basic number system, just drawing on the board, like the exact picture, how much you have on the board, right? So the downside was that it will take a lot of space. So what we came up was that, okay, some smart people came up, hey, instead of drawing actually the goat, we'll draw one stick kind of thing, right? One line. And for two goats, we'll draw two lines. And for three goats, we'll draw three lines. Now it is very compact, and we can have a lot more space on the wall. Four. And for five, this one. But still, five lines, at some point these lines will be big enough. So what we do, we like basically convert it into a small character V kind of thing, right? So that represent five. Now now like first smart move was to represent the goat a single line, right? And again, the if the number goes bigger, then you represent with a bigger character called V, in this case for 5. And one of the lowest, like for the one less than 5, then it will be 4. So this the people were very smart, right? They started using their intelligence, and they came up with this thing, right? And then in the more, as you go forward in the Roman number system, you will find more characters as well. And that was a smart them, and that was a very good. I think this was the first number system, you can say. Rome was the early civilization, probably we can say, and they had this number system, and that worked really well for counting animals, counting dates, and lot more thing, right? Counting a lot of things. and it will perfectly work, and the barter system could go well. But one of the problems with now, this is also, if you know that Roman sister is ancient now, nobody uses it. Like only there are some few application, and that could be also replaced with the current system we have, right? So over here, what we did basically, there was some faults in Roman number as well. So I want to notice what, just question yourself, what was the bad things that Roman numbers had that they led to demolish them or nobody uses it now, right? So can you think of it? Right. So one of them I could tell you, few of them, is basically if you subtract 5 minus 1, it will be 4. If you subtract 10 minus 1, it will be like 9. But if you see 10, right, if you see 10 minus 1, like sorry, 100 minus 1, see basically 100, that will be not, like it will be not simply IC, but it is basically something else like XCIC, like that doesn't matches the pattern. If you see the simple pattern over here, something larger subtracting one, the stick comes in front of it. Over here at the same one, but that doesn't follow the pattern. So they don't have the symmetry, right? A number system is only good where you don't have to remember a lot of stuff. The rules are very generic and simple, and we don't have to remember, and just we can follow the symmetry and we'll probably know about the number. So that was missing from the Roman numbers. They were not following this symmetry, and that becomes very hard to adopt to new people, right? So, like anything, if you want to adopt, if it is too complex, the early implementers will not be comfortable with it. So that was one of the downside, and also to represent and with the Roman numbers, there was a limitation on that it could only represent the number 399. This is the last number I guess you can represent. After that, we ran out of character. Like in Roman number, we can only we cannot repeat numbers more than 3. Like if you remember, three sticks was there, right? So that is the last step. Any character could be only represented not more than 3. So 3 was already fulfilled, right? So same way over here you can see M has been used 3 times, and like most of the, so you cannot have any number beyond this number 399, and there are so many things we can do with counting money and etc which might go beyond this. And even if you see, one of the problem with Roman numbers is that it took like 9 characters to represent this number, which is very big, right? And it's complex. So two of the downfall was, one of the biggest downfall was that it doesn't have 0, right? I will explain later why the importance of 0 is very important. And the other was that there was no symmetry, which we have seen in the previous example, right? And the third was, you can only have this limitation, you cannot go beyond 399, right? So we have so many things to do, but we cannot restrict ourselves to these numbers. So this was the downfall of Roman numbers. So we came up with another Roman number system, which was way better than the Roman number, because that has symmetry, and that was called base number system, right? And this one is base. Basically, what base means is basically after some point, if you remember in the Roman numbers, after 5 we started repeating the 1, 2, 3 again, right? So at some point we start repeating numbers so that we don't have to add a lot of character to remember. So over here in the base 2, you can see 0, 1 has been repeated again and again. Once the one side of the character is full, again we add one more digit in the front, and we go on and on. And for base 4, like after 4, we'll start repeating. So you can see 0, 1, 2, 3, 1, 0, 1, 4, 1, 3, 2, 0, something like this. These are the base 4. The current number system which we use is base 10. So 0, 1, 2, 3. After 9, we start repeating. It was a very common number system back then, because we had like 10, 5 and 5, 10 fingers, and people can use fingers to count, and that was very good enough. Right, so each basis, this kind of number system, we call it a Hindu Arabic number system, and it has a 0 as well to represent nothing, right? Why nothing? Nothing is basically, sometime you want to have placeholder value, right? Sometime you want to count backwards. Sometime you want to associate somebody with nothing, right? Let's say my brother, let's say I'm a caveman, and my brother had 0 zero shape or something, right? And so I have to draw something, right? I have to represent something. Or he had one and now it has been lost, like killed by something. So you need something to represent nothing. So that zero became very much important then. And also help in the repetition of the numbers. After 9, you can use it as a repetition, like you can 10, 11, 12. So this way the repetition went through. So this is the base number system that we use currently, and it has a lot of application. But other base system like binary system, binary base 2, has a lot of application. Like computer uses 0 1. Why? Because computer doesn't have a lot of memory, right? If you see a transistor in a computer, it can only put on and off two values only. So and 0 1 kind of fits over there, right? Only it can hold two memories, and that memories could be 0 1, and then we could continuously repeat more of those, right? But as a human, we can remember a lot of numbers like 0 1 2 3. So we have more memory than computers. Like not the tiniest, the unit memory we call it, right? The unit memory we have more. Computer transistor has only a small unit memory, basically 0 1 it can store, but we can very much differentiate. So every base number has some advantage or disadvantage, right? Even there is something called hexagonal, which is I think 16, base 16. A lot of like what we say compression and these all things are in a lot of computer algorithm it has been used for computer use base 2. And one of the questions I would ask you, like if you ask me, for me like base 12 is the highest, has a lot of advantage, but somehow we are not using it because our early adopter of the our numbers was base 10, and it is now, it is very too late to go back and say people, hey, after 9 we have one more number a and b. Why I'm saying that base 12 has more advantage, like remember, if you remember, that we actually use in real world and we don't know. So this question you can ask yourself: why when we buy banana, it is in a dozen. Dozen is basically a pair of like a group of 12, right? Or the time is from 0 to 12, or the 1 foot is basically 12 inches. Why the number 12 has been used over there, right? When these things are, because 12 has this interesting property, right? If you are a kid right now and who was watching this, probably will not understand you, so you can skip this part a little bit and I'll come back to normal system, number system. But the reason we use dozen as a 12 because it has highest divisibility. Like what many, let's say, I'll tell you by example. Uh, Whenever when we buy stuff, right, we will not always buy a perfect number. Like I will not say give me only one dozen. Sometime I'll say give me one half of the dozen, or give me one third of the dozen, or one fourth. When we buy stuff, it not is necessarily we buy it whole, right? When we buy in terms of kg or whatever, right, we have to always divide. And or something like you can say, and when you divide, you don't want to ruin the object. Let's say I wanted to buy, I don't want to buy one and a half banana, because if I buy the half banana, other half is spoiled, now it is cut. It will not be in a good state so the other person could buy half cut banana. We want like the division is such a way that we don't destroy the object which we are trying to buy. Or you can think in terms of a example, like let's say I'm a father and I have a lot of kids at the home, and I want to buy something and want to equally divide it, right? So let's say I have two kids. So if I buy a dozen of banana, I could equally distribute them 6 6, right? If I have three kids, then I could equally distribute 4 4 4, right? And if I have four kids, then I can equally distribute 3 3 3. So every time I'm distributing equally, there is no fight, there is no quarrel. And only for even for other number, only for I think 5, you cannot distribute properly without cutting it or something. Rest of them it is better. But if you see the number system 10, like if I bought 10 bananas, right? That there the distribution doesn't only holds for 2 and 5. But with 12 we have so much number, we can do with 2, we can do with 3, we can 4, right, 6. And so like the number of divisibility numbers where my divisions are is a whole number is in 12. And also one of the property I would say the base 12 has, that when you if you remember the tables, right? So tables are, if you see, the table of 2 is quite easier, table of 5 is quite easy, right? Because there is some pattern. Table of 10 is much easier, table of 20 easier, because they are divisible of number 10, right? Somehow they are related to 10. So their tables are very simple to write. and we can see some pattern. 9 also have this pattern, right? Table of 9 or something. So if you just write, right, you can probably search another video, what is the advantage of base 12 number over 10. But I can tell you, if you write tables in terms of base 12, you will find lot of patterns when you write tables, what we have in base 10. And the multiplication becomes very easier in base 12. Like if you see, if I have to write a table right now, that will be more simpler. So we kind of for now stick with base 10 because we had 10 fingers and people just initially started with, and it's not that bad, I would say. It's quite good enough, right? But the important one was 12. But somehow we used 10, right? So now that was the advantage, but somehow we still use base 10. Now moving forward, right? This number system was quite good. It kind of solved a lot of problems for us, which Roman number was not able to solve, and that I can show you over here. So let's say if I have to, let's say I have, let's say I have a factory. Like if let's say if you wanted to teach your kids about counting numbers or maybe addition or subtraction, right? The way I have been taught using carrying and borrow, that never made sense. It's like somebody is imposing bunch of bullshit rules on me, and I'm just afraid of my parents and following those rules. So that was not right way, right? How you can teach them in the better way? You can tell your kids that, hey, you are the boss of a candy factory, and there is a bunch of candies like over here, right? And these candies are there, and now let's say I ask you to count 625 candies. So how would you count? So you'll start with 1, 2, 3, 4, 5, 6, 7, like this way you will go on and on and on, like go 625. Right now, if I tell you to subtract 225 from this 625 which you have bought, so what? How would you subtract? The simple and the easiest method a kid will do is that again, oh, he will start counting it back. Right, from the bunch of 625, he'll start counting 1, 2, 3 till 225, and whatever the rest is left, then again he'll start count 1, 2, 3, 4, 5, 6, and then somewhere from around 400 will come, and then he can actually tell you the number. But this is a very lengthy, and this is a brute force. Like it's a very bad way of counting, right? Because you are not using the intelligence that we had, that is the human had. We're just following the simple way of, it will give you answer, but not the right, like not the fastest optimal way of getting answer, right? So to navigate that, we came up with additions, right, or subtraction. So let's say I have a number 653 and I want to subtract it from 2 to 4. How we'll do is basically we'll try to subtract 3 from 4, which is not possible because 3 is a smaller number over here, 4 is a larger number. So we came up with this rule of carry, right? So basically, let me go back. Yeah, so you want to subtract this number, and the right way to subtract is, you can think this number as 6 is basically 600, right? Basically you have 600 stick candies or sticks or whatever you are taking over here, and that will become a like a bundle, like the bundle of, like you can think like you can see this is a bundle of five of the, like you can see the 3 could be represented as 3 candies like this, or 3 sticks you can say. And once the number 5, what this 5 over means is not 5 sticks or 5 candies. Basically you need to group them, you need to group them of 10 groups of 5, right? And similarly the 6 over here represented as 600s. Basically this is the same 10 bundles packaged into another 10, which will become 100. So this will become 100, and then 6 of them, right? Why we're doing it is basically the way I told you, right? The counting one by one, 1, 2, 3, 4, like, and subtracting in 1, 2, 3, 4, 5 by counting is very trivial and very slow. So just like library, if you know, library has this shelf over there, like, okay, the name alphabet A was with this way, the B with this, encyclopedia will be in somewhere, fictions will be somewhere. Why it is that we quickly go and search our book, right? There is system, like there is a previous work done. They have been collected and categorized well off, so that when the need of use, it becomes faster. Same way our number systems, this like a library, we came up with a certain rule that whenever we go across 10, you have to make a group of 10 like this, right? So once the number is 1, 2, 3, 4, 9, till now you can have it in open space. But once it's written, becomes 10, you have to group them and make a bundle like this, right? And once you have 10 of these bundles again, because this is a base 10 number system, right? And anytime you have a anything of 10, it goes to next character, right? So you can have this, once you reach this 10 point, again you have will have more, right? So over here 600 we can represent six groups of 100. One group of 100 is meant through 10 of tens, and this way. So we carry on, and again this 2 will be 200. This will be again two bundles of 10, and the 4. Now if I have to subtract it from here, right, what we can do, if you can see over here is 4 and only over here there is 3. How can I subtract from there, right? So what we need to do, we need to break one bundle from here and make it the part of this thing, right? So this I meant, we'll break it, and now this will become 10 plus 3 13 candies, and now we can subtract 4 from there. So if you subtract 3 from 14 3, then I think it's left with 9. So the 9 candies will be over here, and then the one big bundle has been removed from here. Now from the 4 you can subtract this one, which will become 2 bundles over here, and now this 600 can be like subtracted, and now this becomes like 429, right? And when I when I actually learned it, the way my parents taught me, they told me, hey, take a carry from here. And then I said, why the carry? Because, oh, this number is large or something. But I couldn't understood those rules, right? But if they told me, hey, you can subtract it without understanding carries by just counting 1 2 3 till 600. Then again from there again start counting 224 1 2 3, and then whatever the rest is there, again count back, and whatever the number you count is the number which you're looking for. That will be take me so much time, right? But if tell me, hey, you can do something called pre-processing or pre-categorizing. So whenever you have 600, 200 or 23 number, right? So you can categorize them. 3 is the open single candies which you can keep just as like this, and rest you can bundle them on the group of tens and group of hundreds, right? So that when somebody asks you or subtracts for addition, you can just easily pick out those bundles and break few of them if you require, and then you can quickly process it. So like if you are an owner of a candy store and somebody comes with a delivery like, hey, I need 400, you have in your account you have 600 225 candies or something like this, and then somebody comes, hey, give me 400 of those. So now you don't have to count 1 2 3, like you can use this method, right? So this way I would have understood it better, but didn't understood what the carry and the borrow was, right? Same way for addition as well, right? If let's say I have a number 429, right, and 224. So if you see over here, if you 9 plus 4 is 13, and then they will tell you, hey, this one is extra, you have to add with this thing, right? This was the basic rule that we have been taught as a kid, and nobody told me why we bring this one over here, right? That becomes 5, and this is the number. So if we follow the same method, uh, what we'll do is this 4 become 400, like bundles, like hundreds, bundles of hundreds 4 times, and bundle of 10 2 times, and then the rest of the number. So if there is a 9, this will come 9 plus 4. So 9 plus 4 becomes 13, right? So when become 13, I can group them into tens over here, and 3 can segregate, and then these groups being added, that becomes 4, and this becomes 6. So 653. This is the addition. And over here, uh, the borrow, carry, whatever, you don't have to rule, and which kind of perfectly made sense over here. But the way I have learned was very stupid, right? And I ruined my foundation with that. I think a lot of people has done like this, right? But you need to teach students, right, or kids in such a way, like you can tell them, hey, you are the store of candy, what is the best optimal way? You cannot count everyone and then reduce the count back, right? But if you segregate them in kind of bundle form, for you to do operations becomes very easier. And then we digitalized is, right? Every time you don't have to draw like sticks or imagine sticks in your head, so you can use digits over there. Then those rules quite make sense. So yeah, that was it. That was how we evolved number system, how we did a arithmetic operation, and now nobody has to remember why the carry was there and why borrowing was there, and why we picked the number system with base 10, right? And why dozens has 12, right? Why a foot has 12 inches, right? Or even the time, right? The clock, why clocks has time? Because somebody asked, what is the half of, like, if 1 hour has 60 minutes, what is the half? Like 30. What is one third? That you can divide and you will get a number. Like if you divide 1 by 3 in 10th number system, it becomes 0.333, something like this, right? 3, the 3 repetition. That fraction is never a whole number, right? That becomes very hard to understand back then, people. But if you have 12 number system, you have good divisibility with 2, 3, 4, 5, 6, right? Not with 5, just with the 6. So this 12 has the highest divisibility numbers. So that's why we done. So this kind of thing I didn't understood it, but when I actually started questioning myself where the number system came, why Roman number system failed. Same way in future we would have lectures where we'll understand why fractions were needed on the first place, because this is a good enough number. With this you can do lot of arithmetic, maths, and big businesses and all. But then we came to know why fractions was needed, why decimals were needed, and then we will see why root, pi, whatever, all complex number is needed, right? So every number system has some kind of deficiency, and we keep making amendments over there. We keep changing, and later we have now reached till complex number. I think was the last edition. Maybe in future we become fourth dimensional or something. There will be a new kind of number system, right? So a lot of thing we can explain with this kind of number system, a lot of math, a lot of physics, but a lot of things are not being understood. Maybe these number systems are not enough to make a sense. That's like no Roman number system could not didn't India has negative numbers, right? They could not do so. So maybe we don't have that futuristic number system now. Maybe in the future we have to come up with another number system which which might give the calculation for God, black hole, dark energy, negative energy. There are so many things. Or this number system is enough to explain those kind of things, or maybe you have to do amendments. So probably that will be in the following videos, and gradually we reach quantum computers. So I hope to see you in the next video. So kindly subscribe, do comment, give me a review, any feedback or anything. I love to read them. That really excites me to make more videos like this. So see you in the next one.